than what we had in the Wile E. Coyote situation. What we need to do is break this 28 meters per second up into an initial vertical part and an initial horizontal part. And we'll do that right now. So what I want to do is break that 28 meters per second here up into a horizontal part, which I'll do in red, and a vertical part. So this is called the V in the horizontal initial. This one in green is the V in the vertical initial. We've got the angle here too. It's 2737 degrees. So we need to find this and that. If this is 27, I could call this the opposite side. That would make this the adjacent side because this is the hypotenuse. So I could use just normal trigonometry. That was vertical, this is horizontal, horizontal and vertical. So we have a 90-degree angle. And I can use normal trig to find out what this side is and what that side is. So here we go. 37 degrees, opposite over height. So that's sine. Sine over height, yeah. So sine 37 degrees is equal to opposite over the hypotenuse, which is 28. So the opposite is 28 times sine 37 degrees. So the opposite side is equal to that times that, which we'll do in just a second. By the same token, to get this one, the horizontal, cos 37 is adjacent over hypotenuse. So cos 37 degrees is adjacent over hypotenuse. We know the hypotenuse is 28. So the adjacent is 28 times cos 37 degrees. And we'll just calculate those right now. Cos, make sure it's in degrees, times 28. And I get 22.36 meters per second. That's the horizontal speed, VH initial. So that's the initial speed in the horizontal direction. So it's 22.36 meters per second. And to solve this one, it was 37 sine times 28. So 37 sine times 28. And I get 16.85 meters per second. And that goes right here. That's the initial vertical speed. So it's 16.85 meters per second. That's a lot of info. I've got enough information now to find out the amount of time and even the height that it went to. So let's do that. Just going to erase this side here. It says, what is the air time? The air time is the amount of time that it was up in the air. If you were on a trampoline and you were jumping straight up, you go like this, up, and then that's half your time, and then fall back down. It would take just as much time for you to come back down to the ground. So we're trying to find the amount of time it took to get to the very highest point, and then back down. And there are a couple ways you could do that. You could find the amount of time just to the top, and then multiply that time by 2. It's one of the ways of doing it. So let's do it. A, find time to the top, and then multiply by 2. So the time, I need to get T. I've got A, VF, and VI. So I need an equation that has VI, VF, A, and T in it. And that is VF equals VI plus AT. So this is a totally vertical question because gravity is pulling it down, it acts vertically, so the amount of time in the air is totally due to gravity. So we have to use just vertical information. VF at the very top is 0. VI is 16.85 upward plus minus 9.8 times the time. And when we do the math on this, I don't want T's on one side and numbers on one side. I have to keep variables on this side and get rid of the numbers. So I've got 16.85 on this side. If I move it to the other side, it's minus 16.85. But I'm trying to find the time, not minus 9.8 times the time. So I have to divide this whole side by minus 9.8 and this one as well. So I get minus 16.85 divided by minus 9.8, and that is equal to the amount of time to the top. If I do that calculation, I get 1.719 seconds. So 1.719 seconds to the top. So the air time, the amount of time in the air is just that time times 2. So this air time right here, I just go 1.719 times 2. So Chase had to wait for 3.44 seconds before it landed in his hands. That's the air time. What's the maximum height attained by the ball? It's the distance in the vertical direction when it's 0 meters per second at the top. It's not going up or down anymore. So we'll do that one right here as well. So B says, what is the maximum height? Maximum height is the D in a vertical direction when the vertical speed or velocity equals 0. So it's not going up anymore and it's not coming down. It's just up there, as high as it goes. So I've got a number of bits of information here. I've got VI, VF, A, and I'm trying to find D. So I need an equation that has VI, VF, A, and D in it. And that equation is VF squared equals VI squared plus 2AD. VF is 0 at the top, squared if you want, but it's 0. VI is 16.85 squared plus 2 times minus 9.8 times D. Okay, I'm just going to clean this up a little bit. I got 0. 16.85 squared is 283.9 plus this is 2 times 9.8 negative, so it's minus 19.6 times D. Okay, I got a number here and a variable here. I don't want that. I just want numbers on one side, variables on the other. So I'll bring that number over to the other side. And I get minus 283.9 is equal to minus 19.6 D. And I have to divide each side by minus 19.6. So minus 283.9 over minus 19.6 and that will equal my D, my height at the top. And that turns out to be 14.5 meters. So this is 14.5 meters. That's different from the distance in the horizontal direction, which we'll get shortly. That is what we need to find. So if we could find the distance that it traveled from here to here, which is when we've got half of the airtime, then we'd have to multiply that distance by 2 to get the full range. If I know the time that it was up in the air though, for the entire run, then I could just go and use one of the equations where this is the full amount of time up in the air. So again, if I use the time that we had here, 1.719, I'd end up getting this distance right here. I just have to remember to multiply it by 2 because it went that distance again. But what I will use is for the time, I'll use 3.44 seconds for the whole length of field, not for half the field. I shouldn't say field, I should say flight of the ball. And if I answer that one here, then I'll have the range, which is the distance downfield that the ball went. So, C, range. I need to use an equation that has VI, well, this VF in the horizontal direction is the same. It's 22.36 because it never changes. So I need to use an equation that has VI, VF, A, and T in it. And I'm looking for D though. So D, VI, T, and A. I could use this one. You can use any other equation that has D in it. You will get the same answer. So D in the downfield direction is 22.36 times 3.44 plus 1/2, so 0.5. Acceleration in the horizontal direction is 0, and it doesn't matter that it's anything because this whole term is 0. So the D just turns out to be 22.36 times 3.44, which is 76.9 meters, which is almost the length of a football field. It's 100 yards. This is probably about 85 yards. So it's a good kick downfield. That's the range. Okay, so that's this number right here, 76.9 meters. And that is that. See ya. Take care.